Okay, so we're trying to do 8.15c, which means that we're trying to find the Laplace transform of the function that's t from 0 to 1 and 1 from t equals 1 onward. Okay, so first things first, I'm Laplace transforming, right?
Yeah.
So that means I'm trying to find the Laplace transform of f of t whoops, I'm saying dt, but that's bullshit. Don't be like that, Joe. Okay, so the Laplace transform is the integral from 0 to infinity of f of t, right? So f of t e to the minus st dt, which in this case is a two-part integral, right? It's an integral from 0 to 1 and also an integral from 1 to infinity. Okay, cool?
Yeah.
All right, so that first integral, what am I integrating in there?
T times e to the, or to
Yep.
the negative st.
Perfect. Okay, and then there's a real tendency to look at that one and think that this junk looks like the Laplace transform of t, right?
But it isn't.
But it isn't. It's not even close. So it's easy to think that, but the bound is what really gets you, right? That this bound is not infinity.
Yeah.
Okay, on the other one, we're adding, and I guess I should clean up my handwriting a little bit here. So we're adding the integral from 1 to infinity, and then in the 1 to infinity area, my f is 1, right? And then I have an e to the minus st. Guys with me?
Yeah.
Okay. Now, the first part is an integration by parts that I just have to do. The second part is almost the Laplace transform of something, right? So my plan here is that this is going to be integration by parts, and this is going to be a u substitution leading to a Laplace from the table. I don't know why this pen is kind of inconsistent over here. Maybe I need to clean my screen. Okay, everybody with the plan?
Yeah.
Okay, so all right. So first bit, integration by parts, you're gonna let u be and dv be. So what's your u? What's the thing you're gonna differentiate?
T.
Good. We're gonna differentiate t. We're gonna integrate e to the minus st then, because that's what we have to do. And then du is gonna be dt, and v is gonna be
Negative s times e to the negative st.
I think
Or,
minus
yeah,
1.
sorry, 1 over. Yeah.
Whoa, buddy, the pinch to zoom on this is crazy. Okay, good. All right, so v is minus 1 over s, e to the minus st. And then this whole thing, oh, what am I going to do with the other one?
Yeah, we do the whole t hat thing. We need to.
Yeah, we're going to do the whole t hat thing. Maybe I'll do it in 2 pieces. So let me deal with I'm dealing with the first integration by parts right now. Let's see. So I get uv is minus t minus t over s, right? E to the minus st minus the integral of v du. So that's minus 1 over s. Oops. What did I lose?
E to the bounds.
Yep. I lost an e to the minus st dt, and then Zach's right, I more importantly lost the bounds. So what were the bounds?
This one's 0 to 1.
Good. This one was 0 to 1. Hot question. What about that? I'm pretty sure I'm not supposed to have t's in here.
Right.
Why is that in here? How do I get rid of it? Oh God, help. Seriously. Help. What did I forget? This thing was supposed to be a definite integral, right?
Yeah.
Like this thing?
Yeah.
And so I was integrating from 0 to 1, right? And this is super easy to do with integration by parts. It's super, super easy to get that uv and then put the bounds on the integral, but forget that the uv part had bounds. So that should be evaluated from t is 0 to t is 1. Does that make sense?
Yeah.
Okay. And then I still have plus the integral from 1 to infinity of e to the minus st dt. I just haven't dealt with that part yet, at all yet. Okay, so I'm evaluating the first bit. So when t is 1, this is minus 1 over s e to the minus s. And then I need minus 0 over s e to the minus s times 0. Which is what?
0.
Good. All that shit 0. And then I have a plus 1 over s integral from 0 to 1 of e to the minus st dt. And then I have plus still the integral from 1 to infinity of e to the minus st dt. Everybody good with that?
Yeah.
Yep.
Okay. So then I have a minus e to the minus s over s minus 1 over s squared e to the minus st evaluated from t is 0 to t is 1.
Mm-hmm.
Plus the integral from 1 to infinity of e to the minus st dt. Somehow that got into the exponent. That dt is not meant to be in the exponent. Okay. Goodsies?
Yeah.
Okay, and then when I evaluate, I get minus... Go ahead.
Nothing, that's just your volume peaked again randomly.
Oh,
Yeah,
sorry.
you kind of just broke our ears.
Oh, I'm sorry. I don't know where the microphone is on this thing. Maybe I'm bumping it.
Maybe.
Okay, so I have minus e to the minus s over s minus, let's see it, t is 1. This is 1 over s squared e to the minus s, right?
Yeah.
Yeah.
And then it's minus 1 over s squared e to the 0, which is 1. Pretty good with that?
Yeah.
Okay, now let's see if we can tackle this other part. Okay, so on the other part, I kind of need this 1 to become a 0, right?
Yeah.
So I need to let the new t be the old t
-1.
minus 1, and then the new t's differential is just going to be the old t's differential. You guys with me?
Yeah.
Okay, so then I'm going to have plus the integral from now 0 to infinity of e to the minus s times
T hat
t hat
plus 1.
plus 1. Very good. dt hat. Everybody with me on that?
Mm-hmm.
Yeah.
Okay. And that is that stuff plus, and then this thing I'm using an exponent rule on. So that's going to be an e to the minus s times the integral from 0 to infinity of e to the minus st hat dt hat. You guys buying that?
Mm-hmm.
Okay, which is the same stuff plus an e to the minus s times, what is that stuff the Laplace transform of?
1.
Good. So that's plus e to the minus s times the Laplace transform of 1, which is 1 over s. And so in the end here, I have an, sorry, I need to scroll back up so I can see what that was. A minus e to the minus s over s minus 1 over s squared e to the minus s plus 1 over s squared plus e to the minus s times 1 over s. And then we might see that this stuff cancels. And so I get 1 over s squared minus 1 over s squared e to the minus s. Questions, concerns, deals?
No.
So, how does this tie in with that heavy side thing you just showed us?
Okay, good. So if I wanted the heavy side version of this, I would look at, so I scrolled back up to the top if you're on this storm. So I'm looking at this thing, right? And I'm thinking that's t to start, right? And at time 1, turn t off, turn 1 on. You guys with me on that?
Yeah.
So I would write f of t is, well, it's t to start with, right? And then I need an off and an on. And this is at time 1 that things are happening. So I'm doing this unit u of t minus 1 and u of t minus 1. And the thing that I'm turning off is a t, and the thing that I'm turning on is a 1.
Okay.
And you can then look these up in the table if you want. Right now, I want to illustrate that they can be rewritten and that those exist in the table. The table is just a little more subtle to deal with than I'm making it seem like it is. Any questions on the rest of this? How many of you have fallen asleep?
I'm still here.
I'm still here.
Yeah.
I'm awake.
Is there a non-response bias from the people who are asleep?